So for electronic systems, we can also easily import it describe it with the use of Simulink. Apart from Simulink, for electronic systems, the commonly used tools are, for instance, Tango or electronic workbench, Protel, multi-sim, and program normally used. And also there is a very famous language called Spice language. And there are quite a lot of circuits described by Spice languages. For this kind of circuit, we can easily describe it by a Spice language. So our question is, if you have already some circuit described by Spice language, how can we embed such a circuit in Simulink rather than drawing the block diagrams like this? And if you do not want to draw block diagrams like this, if you have quite a lot of existing Spice language programs, how can we embed it in the Simulink block diagram? So this is the question I want to ask. So with the use of a new command called Matlab2SL, it can be used to convert a Spice program into a Simulink block. And then you can use the Simulink block if you are using command like this, then I already have that program in the file, in the folder. If you have a piece of code written by Spice language, then a Simulink block diagram will be click look under mask menu item, and you will see that these are the simulation diagrams generated automatically with the use of generated from the Spice program. And you can embed this Simulink block inside your simulation system. And also, I think you can create other kind of simulation programs, for instance, power electronic systems. You can easily model it with the use of Simulink. And also, you can model mechanical systems as well. If you do not have a good knowledge of mechanical system, you can also create a mechanical system simulation block diagrams, just in the way as you did to assemble real-world systems. So the tools for mechanical system you can use are the Simulink itself, and also there is a tool called Sim Mechanics, where you are allowed to model, for instance, the body, the rigid body, the joint, and other things with the use of blocks provided here. And also, if you are familiar with software like SolidWorks or other software, I think there is a converter to translate a SolidWorks program into a Simulink block diagram. And also there are things like Sim Hydraulics to model hydraulical systems with cubic blocks. Apart from this, if you are familiar with other languages, for instance, such as if you are familiar with elements, which is also used in simulation of mechanical systems, you can establish the interface between Simulink and elements to perform combined simulation. So there are quite a lot of choices you can use to simulate mechanical systems. And here I shall only display a few examples. One is a spring with a damper, how it can be demonstrated and what should be the output of the system. And then I shall explain with animation the pendulum system and also the four-bar mechanisms and also the manipulators. So let's consider a simple spring and damper system. How can we model that part? So let's start scene-scape. And in scene-scape, you will see that there are quite a lot of things like mechanical, and we have mechanisms and translational elements for damper and spring system. Mechanisms. That's strange. The version is not the same as that. That's why I use it for the demonstration. And damper. So I will open that window first. Example 1. Example 1. Well, for the system, I think we can use the component separately. One is the spring, one is the damper. So we can connect them together. And then there should be frictions here, and then we can establish the system, and then we can simulate it. So this part is quite similar to the real-world system. We have spring and damper here, and there is a mass on the surface. And apart from this, we should have the signals, the physical simulating to physical signal conversion, and the physical system to simulating conversion. So the signal conversion like this. So we can easily find the output of the system. We do not have to have good knowledge on mechanical systems, and we can make the simulating model and find better results.